In Iceland, there are many geothermal factories that release many gases in the atmosphere. Some of them are bad in a huge quantity, such as CO2 gas. To resolve this problem, scientists found new ways such as the most efficient is to solidify CO2 in the soil. The research of this technology started in 2012 in the factory of Nesjavellir. It is unique to Iceland for now. We asked ourselves if the CO2 stocking into a solid form is reproducible at world scale.
The solidification of the CO2 follows a few steps to be accomplished. Firstly, the CO2 is injected at high pressure in water to avoid leakage. The process needs 25 tons of water per ton of CO2, whatever if it's seawater or not. Then the mixture is sent at 1,500 feet of depth in the basaltic rock. This way it becomes a crystal, thanks to the minerals present in the basalt. In fact, the minerals in the basalt, like calcium, iron, magnesium and manganese, become unstable and are dissolved by the acid condition that the CO2 creates. Then it forms a mineral close to limestone which traps the CO2 and permanently binds with the basalt. It is an efficient way of stocking CO2 as 95% of the gas are going to be transformed after 2 years.
The solidification of CO2 needs lots of water to be done, and it requires basalt or it will take thousands of years to be accomplished. For example, if we wanted to solidify the whole CO2 of 1 year of Chinese emission, it would need 266 billion of tons of water. It's also expensive as it actually costs twice the price of the other methods of stockage. But it means $17 per ton of CO2, so $170 billion per year for China. But nowadays, no consequences on Earth have been found. We can imagine that if it was used at high scale, it would disturb the water cycle. Moreover, basalt can be found in the oceanic crust only.
To conclude, we can say that this technology is new and maybe not mature yet. Consequently, we can think that after more years of research, this method will cost less money and will be more efficient. But for now, it's impossible to use it at high scale because of the resources it needs and it costs. But this domain of research have a high potential, it just needs more time to develop.